Hi folks, we're going to take a look at the solution for page 217, number 9. So here it's a question about somebody flying their kite, and it gives us some information. So it says the kite starts off, so it's on a string 40 meters long, and it starts off at an angle of pi over 4 to the ground. Okay, so now here hopefully you're starting to get a little comfortable with these special angles, and we know that pi over 4 is the same as 45 degrees. So I'm going to try to draw it a little precisely here. So pi over 4. Okay, and we know that the length is 40 meters. Okay, and then what happens is there's some wind, and so now the kite's going to be flying at an angle of pi over 3, which again is similar to 60 degrees. Okay, but the length of the string stays the same at 40. Okay, if you want to do number 10 as a similar problem to practice, you'll notice there's a little added layer of complexity where the length of the string changes. Okay, but here we've got pi over 3. Okay, and when they want us to find an A and B are the differences in the horizontal and the vertical distances. Okay, and then in part C they just want approximations for that. So given that we're working with special angles, there's a good shot that we should be able to come up with an exact answer. Okay, so here best thing to do is to create some right angle triangles here, because once we create these right angle triangles we realize that we can easily find the difference in the horizontal distances. So I'll call that delta D, and then here we see the difference in the heights. Okay, the vertical distances. So I'll call this delta H. Okay, and how are we going to find delta D? Well, you just start here. We'll start with the longer distance. So we'll call this D1. Okay, and we're just going to have to subtract D2. Okay, D2. Okay, whereas here the higher vertical distance, okay, is going to be H2. Okay, and here the shorter one was the original one, H1. Okay, so let's start with A. So for A, they want us to find the exact value for the difference in the horizontal distances. Okay, so what we're looking for is delta D, okay, which here is going to be D1 minus D2. Okay, I'll just set it up so that I know I'm going to get a positive answer. Okay, and now for D1, let's see what's going on here. Okay, so let's say for D1, that's just the base of this pi over 4 right angle triangle. Okay, so we have cos of pi over 4, since it's the adjacent side, is just equal to that adjacent side D1, okay, over 40, which is the hypotenuse. So that can be written as 40 cos pi over 4. Okay, so here we have that's equal to D1, which is 40 cos pi over 4, okay, minus, now D2 will be very similar, except instead of being cos of pi over 4, it's going to be cos of pi over 3. So it's going to be minus 40 cos pi over 3. Okay, and there we have it. That's essentially the difference in the distances. So the only thing we have to do now is just the arithmetic for calculating that. Okay, so here we have our pi over 4 triangle, which we're going to have to use. So that's just 1 root 2. And then, of course, we're also going to use our pi over 3 triangle, which is 1, 2, root 3. Okay, so not a bad idea, to sort of draw these out if you need them, especially if you have to do it a few times. Okay, so here we have 40 cos of pi over 4 is just 1 over root 2. Okay, and then here minus cos of pi over 3 is just 1 over 2, so 40 times a half. Okay, so let's just simplify this here. So here we've got 40 over root 2 minus 20. Okay, now here how far you have to go, I guess I would expect you to put this as one fraction. So at the very least I would expect this next line where I put them in one fraction. So here my common denominator is root 2, so this will be 40 minus 20 root 2. Okay, whoops, don't need that. Let me just get rid of that so it looks nice. Okay, and I'd probably be fine if you left it at that, but I think the book will probably rationalize this, so let's just see how that goes. In order to rationalize this, I have to multiply numerator and denominator by root 2, so I end up with here 40 root 2 minus 20, and root 2 times root 2 is just 2. Okay, and root 2 times root 2 again is just equal to 2. Okay, and so here we have 40 root 2 minus 40, which of course is just, over 2. And of here we can just divide 2 into both of those. So we just end up with 20 root 2 minus 20. And there we go. There's the exact answer. So for now, let's answer that part of C, which asks us for an approximation. Okay, and so here, let's just get an approximation here. So what do we got? We got 20 times square root of 2. Okay, minus 20. Okay, so we have about 8.3, and I guess here it's meters. Okay, so now I'm going to do something very similar for part B. Okay, to find delta H. So again, delta H is H2 minus H1. So here H1 will be from the pi over 3 triangle. So I'm not going to go through this process again. In this case here, it's just going to be 40 times sine of pi over 3. Okay, since I'm working with the opposite side, and here I'm going to be subtracting 40 times, okay, the height from the pi over 4 triangle will be sine of pi over 4. Okay, and now I'm just going to do the same thing here. So 40 times, okay, you can go back to your triangle, sine of pi over 3 is just root 3 over 2. Okay, minus 40 times sine of pi over 4. Okay, of course, is going to be the exact same as cos of pi over 4, 1 over root 2. Okay, and so here we've got 40 over 2 is 20, so 20 root 3 minus 40 over root 2. And here, let's rationalize this for fun. So here we've got multiply root 2 to this here. So we have 20 root 2 times root 3 is root 6 minus 40 all over root 2. Okay, and now if we want to rationalize this again, multiply numerator and denominator by root 2. And again, when you're doing that, make sure you're multiplying it to both terms. So here, 20 root 6 times root 2 is root 12 minus 40 root 2. Root 2 times root 2 is 2. Here, again, we can divide the 2 out to both. So 10 times, and be careful here because root 12 is actually 4 times 3. So root 4 is 2. So this becomes 2 root 3. Minus this just becomes 20 root 2 because I'm dividing out the 2. And in the end, we're just left with 20 root 3 minus 20 root 2. Okay? But again, I wouldn't be averse to you just leaving it in this form here. And again, for part C, let's find the approximation here. So what do we have? We've got 20 times square root of 3. Okay, minus 20 times square root of 2. Okay, which is about 6.4 meters. Okay, so just to do a recap here, number one, it's important to see that this is just a regular old trigonometry problem that you could have solved back in grade 10. Okay, the only difference here is that now we're working with our radian measure angles. Okay, but everything else is exactly like what you would have solved back in grade 10. Okay, but notice how it's important to set up the problem correctly. And a question like this, which has a physical interpretation, drawing a picture, I'd say is almost essential. Okay, that's it for this one.